Let's take a look at some of these one-sided limit problems now. And we know it's a one-sided limit because there's a plus sign given in the problem here. So we're not going to factor this or times it by the conjugate. Instead, we're going to use a number line to solve these kind of problems. Now, if you think about this, and if you plug a 3 in here, basically you should kind of have an idea that you're actually approaching a vertical asymptote. So we want to know how the function is behaving when we approach a vertical asymptote, and really there's two options for that. It's either going to be plus infinity or minus infinity. Okay, so by using my number line, since we're approaching 3, we should definitely put the number 3 on the number line here. And we're approaching it from the right-hand side. So here's my right-hand side. And I need to find any number on the right-hand side. So maybe I'll pick maybe 3.01. And then we're going to do a direct substitution step now, where we have a 2 on the numerator. And now this x here, I'm going to change that x with 3.01. So 3.01, and then we minus the 3. And then what we're doing now is we're just seeing if the numbers are positive or negative, right? So the numerator is positive, and the denominator is also going to be positive. So positive over positive is positive infinity. So the limit is reaching a, so when we're approaching the vertical asymptote, we're going straight to positive infinity. Okay, so I have a little graph here of the function that's given to us in the problem here. So I just want to explain what we're doing in this kind of a problem here using a visual here. So this is the graph right here, and let's just say 3 is around here where the vertical asymptote is, right? Now if we're approaching 3 from the right hand side, basically we're going in this direction, right? So as I approach 3 from the right hand side, notice that we're approaching a height of positive infinity. Okay, so that's the answer that we just discovered by using the number line, right? So this positive infinity is equal to that, right? Okay, so that's basically what we're doing for some of these one-sided limit problems. We're just trying to figure out what's happening as we approach that vertical asymptote. Okay, so let's move on to question number 2 now. It's another one-sided limit problem because of this minus sign. So this time we have the number 2 in the middle. And since we're approaching it from the left-hand side, we need to pick a number on the left-hand side of 2, and maybe we can pick maybe 1.9. And then from there, we do a direct substitution step here. So this will be negative 1 divided by 1.9 minus 2. And all we care about is if the numerator and denominator are positive or negative. So if I look at the numerator here, the numerator is definitely going to be negative. And on the denominator here, 1.9 minus 2, that's also going to be negative. So a negative divided by a negative is going to be positive infinity. And that's it for question number 2. For question number 3 here, I guess the number that we're approaching here is now negative 3 from the right-hand side. So let's put a negative 3 on the number line. And if we're on the right-hand side here, we need to pick a number on the right hand side, so maybe negative 2.9, and then let's go ahead and apply a direct substitution step here. So all the x's now, they're going to be replaced with negative 2.9. So negative 2.9 divided by negative 2.9 plus 3. Okay, so on the top, that's definitely going to be negative, and on the bottom, that's going to be positive. So this is going to be negative infinity for this final answer for question number 3. Okay, moving on to question number 4. So for question number 4, I noticed that if I plug in 2 there, we get 0 on the denominator. So there's definitely a vertical asymptote at 2. But for this question here, I guess we need to do 2 limit statements. So I need to take a limit as we approach 2 from the right of 1 over x minus 2. And we also have to do a limit statement as we approach 2 from the left. Alright, so if we're not given a positive or negative direction, we actually have to do both of them to find out the overall limit. Okay, so let's go ahead and put 2 in the middle here, and we have a left-hand side and a right-hand side. On the left-hand side, let's just pick 1.9, and on the right-hand side, let's pick, 2.01. Okay, so on the right-hand side, this will be 1 all over. X will be 2.01 minus 2, and if we go ahead and evaluate this, the numerator is going to be positive, so that's going to be positive there, and then the denominator here, that's also going to be positive, right? So positive over positive is positive infinity. Okay, now let's figure out the left-hand side. So this x is now going to be replaced with the 1.9. So this will be 1 over 1.9 minus 2. So this will be positive on the numerator and a negative sign on the denominator, so that we have negative infinity there. Okay, so we just discovered now that the left-hand limit does not equal to the right-hand limit, so that means the overall limit does not exist. Okay, and just before I go into question number 5, what does that mean the limit does not exist for this problem? Okay, well here's a graph right now. So this is the graph of the function that's given to us in the problem, which is 1 over x minus 2. And I guess here is your vertical asymptote here. And as we approach 2 from the 2 from the right, we're going to positive infinity, but if we approach 2 from the left, we're going to negative infinity, right? So that's why the limit does not exist. All right, let's move on to question number 5 here. So question number 5, same situation as the previous one. We have to do 2 separate limits here because we're not given a specific side here. So if we're not given a plus or minus, we actually have to do both of them here. So this is going to be a negative 4 over x and negative 4 over x. So we need to compute 2 limits here. Okay, well, I guess 0 is in the middle because that's the number that we're approaching, and we have a left-hand side and we also have a right-hand side. Maybe on the right-hand side I'll pick 0.1, and on the left-hand side I'll pick negative 0.1. And then we'll do a direct substitution here. Okay, if I do a direct substitution here, I get negative 4 on the top, and on the bottom, on the left-hand side, I get negative 0.1. Okay, well, I guess on the left-hand side here, it's gonna be negative over negative, which gives you positive infinity, right? So both the top and bottom are negative, and 2 negatives gives you a positive, so positive infinity there. Over here I have negative 4 over, I'll say positive 0.1, and once we compute that, there's the numerator is negative, but the denominator is, the numerator is negative, but the denominator is positive, so this gives you negative infinity here. So for question number 5, this is also going to be a does not exist because the right-hand limit does not equal to the left-hand limit. So does not exist for question number 5. Okay, so we move on to question number 6 here. Question number 6, this is a little bit better because now they're telling us the side that we're approaching was the left-hand side. So let's go ahead and plug 3 in the middle here. And then let's take a look at the left-hand side of 3. So maybe a good number that we can pick is 2.9. Alright, so if we do a direct substitution here, we're taking all the x's and replacing those with 2.9. So this is going to be bracket, whoops, let me start all over again. So negative 1 all over, and then bracket, I have 2.9 minus 3 all squared. Okay, well, the numerator is negative, right? So negative on the numerator. But the bottom, because of this squared here, the bottom is always going to be positive, right? So negative over positive is going to be negative infinity there. Okay, so that's it for that question. Let's go on to question number 7 now. Okay, so question number 7 is also a bit tough here because we're approaching 4, right? But I don't know if we're approaching it from the left or the right, so we need to do 2 limit statements here. So as x approaches 4 from the left, and we also have to do a limit as x approaches 4 from the right. And my function is 2x all over x minus 4 all squared. And I have a 2x over here all over x minus 4 all squared. So we need to evaluate 2 different limit statements here. And let's go ahead and plug 4 on the number line there, and let's create a left-hand side and a right-hand side. And on the right-hand side, I can pick 4.01, and on the left-hand side, I'll pick 3.9. Okay. Alright, so as I'm just about to do a direct substitution step here, I notice on the bottom there's a squared, right? So if you're squaring the bottom, it really doesn't matter what number you're plugging in there. You're always going to have a positive on the denominators there because you're squaring the results. Okay, so on the left hand side I can plug in 3.9. So this will be 2 times 3.9, and 2 times 3.9 is going to be positive, so positive over positive is going to be positive infinity over here. And if I calculate over here 2 times 4.01, that's also going to be positive, right? So positive over positive is going to give me positive infinity here. So for question number 7, I get a positive infinity as a final answer because the left-hand, right-hand limits are approaching positive infinity. Okay, so move on to question number 8 here. Okay, so this one's okay, I guess we're approaching okay, so unfortunately I have to do this the long way here because I'm approaching 3 from the left, and I'm also approaching 3 from the right of 1 over the absolute value of x minus 3. Actually, you know what, I'll put this in a different color here. Absolute value of x minus 3 and 1 over the absolute value of x minus 3. Okay, so this one here, I mean, I guess we can apply the same strategies here. So there's a 3 there. I can pick 3.01 and 2.9. And I mean, over here, if I plug this in, I mean, I get 1 over the absolute value of 2.9 minus 3 absolute value, and 1 over the absolute value of 3.01 minus 3. Now this one's not too hard to calculate because the denominator is always positive, and the numerator is also positive, so you get positive over positive, so I guess this answer is going to be positive infinity here. Okay, so some of these one-side limit problems, we have to do a left-hand and a right-hand limit, which takes a little bit more work. Hopefully we can do a few more of these one-sided limit problems. And for question number 9, we finally get another one-sided limit problem. So the number in the middle is going to be 0. And we're looking at the left-hand side, so maybe a negative 0.1. And let's go ahead and plug that in now. So I have negative 0.1 divided by the absolute value. Oh, wait, hold on. Okay, so let me just kind of look at this problem here again. Sorry, I didn't realize that this is an absolute value problem here. And what we have to do here on this particular problem is that there's different ways you can do this, but I noticed that there's an x and an x on the bottom, so it's almost like the same function over the same function. And when you're dealing with absolute values, and if you're given a negative sign, all you have to do is get rid of that absolute value sign. And the way that you do that is that since you're approaching from the left-hand side, the absolute value just changes to a negative sign with x. And then if you compute this algebraically, this divided by this gives you the 1, and then the minus sign tags along. So the final answer there is negative 1. So for this particular question, I don't really recommend doing a number line for this particular problem here. I mean, if you want, you could definitely put a 0 there, and the left-hand limit, sorry, the number on the left-hand side would be negative 0.1. And then if you kind of plug that in, you get negative 0.1 divided by the absolute value of negative 0.1. And what you have to recognize is that these numbers here are pretty much the same, right? So the same number over the same number is going to be 1. The bottom is going to be positive because of the absolute value signs, right? But then you have this minus sign tagging along, which gives you that minus 1 as well. So if you want to use a number line for these absolute value problems when you have a same function over same function, you can. And but I recommend just algebraically getting rid of the absolute value signs if you have the same function over the same function. Okay, so let me see if I can teach that concept again for this next question here. So it's an absolute value question, but what do you notice about the top and the bottom? This is what I was referring to as the same function over the same function, right? So if you're dealing with the absolute value from the right hand side, the trick is that you want to get rid of the absolute value, and since you're approaching from the right hand side, you just remove the brackets and you get x plus 2. And then notice that these will just cancel off, giving you just a positive 1. And it really doesn't matter about this negative sign there. It's really testing if you understand how to remove the absolute value signs. Okay, let's move on to question number 11 here. And for question number 11, it's another absolute value problem here. And I noticed that x minus 2 and x minus 2, we have the same situation where we have the same function over the same function. So what we're going to do is we're going to get rid of the absolute value signs. And for this particular problem, we definitely have to evaluate the absolute value side from the left-hand side. And we also have to evaluate the absolute value function from the right-hand side. Now, when you have the left-hand side, all you're doing is you're getting rid of the absolute value sign and putting a minus sign in front. That's it. And if you're dealing with the absolute value on the right-hand side, you just completely remove the absolute value and you just have x minus 2. Well, for this one, this and this cancels, so that gives you positive 1. And I notice that this and this cancels, that gives you the 1, but you still have this minus sign tagging along, so you have a negative there. So notice that the left-hand limit and the right-hand limit are not equal, so this is just does not exist. Great. Okay, just a few more questions to go for this homework video guide. And for question number 12, now we have a few more one-sided limit problems. So let's put 2 in the middle here. Now we're dealing with the greatest integer function here. So if I approach 2 from the left-hand side, maybe I'll pick 1.9. And what we're doing is we're calculating the greatest integer function there. So this x gets replaced with 1.9. And if I want to find the greatest integer function of 1.9, we always round down to the closest integer, which is 1. Okay, so if you're on a number line like 1.9, you're rounding to the closest integer to the left, which is just 1. And that's how you get that particular answer there. Okay, moving on to question number 13. This time we're approaching negative 2. So let's put negative 2 on the number line, and we're approaching it from the left-hand side, right? So here's my left-hand side. Maybe we'll have negative 2.01. And if we go ahead and if we complete a direct substitution here, so negative 2.01. All right, so we always round down to the first integer on the left-hand side. So if I keep on going this way to the left, the first integer that comes up is negative 3, right? So my final answer here is negative 3. Okay, question number 14 here. I believe this is the last question of the homework video guide. So now we're approaching negative 6 from the left. So let's go ahead and plug in a negative 6 on the number line. If I'm on the left-hand side, maybe I can pick negative 6.01. And if I go ahead and complete a direct substitution step here, I have negative 6.01 divided by 2 with the greatest integer function around it. And if I go ahead to my calculator and compute that, I get negative 3.005. And then once again, if I round to the left, I guess the first integer that should come up on the left of negative 3 will be negative 4, right? So once again, if I had to erase this number line here, if I had to put negative 3.005, and if we're going to the left, the first integer that comes up is actually negative 4, which is the answer there. Okay, so that concludes this homework video guide.